Part B and C are just extra. That comes from different chapters where we're going to ask you about, distances or velocities or whatnot. And those pieces are when you're going to bring in those old acceleration formulas. So it's a wonderful opportunity for me to bring in old material and merge it with the new. And that's not going to go away in this course at all. Old stuff will always be able to be merged into the new stuff. That's why this course is always cumulative. So in B, I'm asking about the distance traveled. And so, again, this is an acceleration situation. So we know delta x, we know v1, v2, acceleration and time. So those are our acceleration formula variables. I'm asking for this. I'm also asking for this in part C. We know the starting velocity is 0 meters per second. We know the acceleration now is 2.06 meters per second squared. And I know the time happens to be 4.0 seconds. I had given that. So in the first situation, they want to know time. Probably the best formula to use for time, or no, the first one we want to use, wow, Tapper. Yeah, no, we have time. Oh my goodness, Tapper. We have time. I want to know distance traveled. Wow. Okay, so we want to use this one. We want to use good old classic 1/2 AT squared. Initial velocity is 0, so I can go away. So delta x is 1/2 2.06 times 4.0 squared. So let's take this number and basically we're going to multiply by 16.5. So that's part B. And then part C, we do want to know the velocity at 4 seconds. And I would probably just go like this, and we know this is 0. So we can take that 2.06 and multiply it by 4. And velocity 2 would be equal to 8.24 meters per second. So that is our answers to the second and third part. I hope this problem made sense. We have, I think, 4, 5, 6 more to go. So I'm going to move faster on the next several problems for certain aspects. But yeah, this is just one problem. And they're only going to get more complicated. So please follow along. And please, if you discover that you are not getting things, reach out as soon as possible. Do not let this linger or wait. If you let this linger or wait, you will be so lost so quickly, it will not be a pretty sight. Okay? So, all right, let me get set up for the next problem. I did forget to make mention previously in part A that when you calculated this part here, I didn't show the value off by itself, but if you just were to calculate that, that is your value of friction. So if you put that into the calculator and get that number, the frictional value is a little less than 59 newtons, 58.9. So this value would have been 58.9. So I just wanted to point that out. So when you get these numbers in the statements, remember they actually mean something, right? The 100 is the pushing force, the 58.9 is the frictional force. Good thing that the pushing force is greater than the friction. That's why it's going to move. That's why it's going to accelerate, and so forth. So same thing. pretty evident that this number over here, that is your, obviously your normal force, but remember that was actually calculated from the weight. So that's the one thing with physics. You're going to work with a lot of numbers, but remember those numbers have a physical meaning, and you should always ask yourself, well, what is the physical meaning of what I just calculated? All right, awesome. Get ready for the next set of problems.